So how can HBK help with drive cycle testing and dynamic power? Question I'm sure you're all wondering. And we do have a really powerful tool, so please stay tuned in. We have some key benefits, and here's our HBM Power Analyzer. One of them, we have a variety of sizes, and this is the beast I'm going to be talking about. We have transparent data and equations. We record every data point, and we give you all the equations so that you know exactly what data is being used to make a calculation and how the calculations are being executed. And if something goes wrong, you can rerun a test in data. Our test setups are flexible for many channels. We can measure more than 50 power channels into one common data file, so that even for your most complex vehicle setup, you can make a little graphical user interface, understand how each component uses energy, and have this really flexible setup where you can configure it to look how you want. Again, we record all the data, and we have a wide host of triggering. So if you just want to record power values for the whole 10 hours, but every time pump 3 kicks in, you want to trigger and record that data, you can have high rate data on the triggers and low rate data for the whole test. We can do a lot of cool things with data so that you can really understand how your test is executing and make those difficult decisions when you're updating your vehicle controller or you're doing your vehicle energy management decisions on components. We can also bring in CAN into the same data file. So while you're measuring these real signals, these real powers and energies, we can measure the CAN bus to understand what the vehicle is thinking as well as reality. We have some great features for our dynamic power measurement. I'll speak up more on those in a minute. And we have the highest DC accuracy and very high accuracy for a wide variety of AC frequencies. So I'm going to elaborate on a couple of these points, and I think you'll learn something. So our testing is auditable. All the data is recorded. All the equations are public. And what we're doing is eDrive is storing all the signals to the hard disk, to the hard drive. And we have some new data modes for extended testing, where in the example on the right-hand side, I'm just recording RMS and power values. So I have my RMS voltage and current, and we can see those kind of changing state here over a small segment of a drive cycle. So we're speeding up, slowing down, speeding up, slowing down. We're doing some maths to figure out our speed. We're doing some maths to calculate our power, and we can see, during this acceleration, we have some power. Over here, we have some regeneration where we can really understand how the vehicle is regenerating. Regeneration is a big part of this. And then we're calculating that energy, see how the vehicle uses energy, how we put it back into the battery, how we drain it. And we're even catching transients. And this was a machine actually experiencing some airborne activity where the power levels fluctuate greatly. But this could be a transient, this could be a clutching in of another machine. We understand in great detail, because we're recording the data at a high rate, what's happening in the transient scenarios. We can allow you to set up custom equations. So if this energy calculation, we want this to involve 2 or 3 motors or a subtraction possibly, we can do calculations for that. You can understand how all calculations are done. And we have a wide variety of custom equations that allow you to adhere to standards today, because the standards today might be different than in the future. And because we give you the ability to edit the equations, not only see them, but edit them, you can update your equations to match what the standards are. If that means we're going to higher update rates, or that means we're going to different calculations that need to be used, you can be resilient to that. So really cool stuff. Again, we're flexible for many channels. So this is an example of, we have a battery, 2 inverters, and 4 wheels. And we map this powertrain to have our battery, our DC power, our 2 inverters. We can look at the energy of each component, and then we can understand kind of the gear and system level losses by looking at the wheel torque. But we also have things like HVAC, infotainment, cooling pumps, heated seats, and we can add expansions for these as well and understand how each of these use energy as well. So we can really start looking at, again, how each component uses energy in the vehicle. The cool stuff, and this will help with the engineering range test. And I should mention, this is a feature in our software where you can set this up and look at this configuration and have a visualization. So this is taken from our software. Trying to make life easy for you. We have the highest DC accuracy and this cool thing called cycle detect. So cycle detect is how we measure dynamic power. It's what lets us be one of really the only people in the market who are doing this very well. We have our phase A current coming in red, and we're monitoring for zero crossings. We take 2 successive zero crossings and we get this little square wave. This is our cycle time. We're doing our power efficiency, reactive power, energy calculations on this half cycle basis, which really makes us extremely accurate in the dynamics. This is a really powerful tool because if you're ramping up speed, ramping down speed, you have confidence that your power measurements are correct and catch things like those reactive power overshoots or that extra power during transients. And we have this just really killer accuracy, so you can be confident that your measurement is as good as possible. What cycle detect allows us to do, and this is just an example of a dynamic test with cycle detect, where we had a vehicle that started moving, and we can see the currents start, and the currents are in red, and our cycle detect is just tracking that current as it's ramping up in both torque and speed. So we can have a lot of confidence tracking that. On the bottom, I have my power measurements, so I have my real reactive apparent power, and we can follow that power like a scope trace. And we can really start to understand the details of how that controller is executing that vehicle level control. We can see things like power overshoots, and we can start to understand how each component uses energy in either that certification level test, in that engineering test, or in that component level test. We can really understand the dynamics of those real world scenarios. Super powerful tool for understanding how our power energy is being calculated and trust it in those dynamics. We offer feedback, so we do all those measurements in the unit. We can feedback those values to the dyno and act as a smart sensor. Because we're executing all our equations in real time, we can feed those back. We can also pull data from the CAN bus or correlate to CAN so that we can have that system level understanding. But we can communicate with that automation system, have the user visualize everything in the lab, and be off to the races. So, conclusion, range testing is a really important part of vehicle certification and marketing. You know, we need to have that range to market, and we need to have the longest range possible to sell more vehicles. There's a lot of challenges in measuring. We need to understand what the equations are. We need to understand the individual data points going into that. And we need to do it for a really long time. We need to measure this test for hours and have confidence that we're getting accurate measurements. Testing can be done on a component level, a chassis dyno, or in some instances in vehicle. And I didn't touch on this, but some of these drive cycles do have an in-vehicle component. And lastly, HBK, we have a really great knowledge set on this. We have some really great tools for understanding vehicle power flow and drive cycles. And we'd be happy to discuss anything further with you and how you can potentially bring these tests into your own lab. With that, I'd like to thank you. Please shoot any questions. And if you want to learn more about products, feel free to scan this with your phone and peruse what we have. So with that, thank you, everybody, and look forward to speaking with you.
All right. Thanks, Mitch.